Hey guys, it's Mr. Dugal, and today we're going to talk about percentages in terms of making a comparison and how that relates to just using the actual statistics itself. So we have an example here, a basketball game that was played, and I asked the question, who is the real MVP? I know in basketball we don't just use points to determine an MVP, but for this case we're just looking at points. Player A had a great game as he led his team in scoring with 32 points in the team's 110 to 104 win last night. So player A had 32 points and his team had 110. So there's our player, and over here is our team. Player B helped to lead his team to victory, scoring a team high 25 points and helping his team win 81 to 79. So in this case, the player scored 25 and his team scored 81. So when we go to compare these two players, the common person would look and say player A is the MVP because he scored 32, whereas over here, player B only scored 25. However, a closer look and evaluating it with percentages may or may not tell us the same story. Sometimes it will. Sometimes the person who scores the most also has the higher percentage, but not always, and I'll show you what I mean. And in order to find percent is always the part divided by the whole times 100. Basically, when you do the part divided by the whole, it should give you a decimal, and when you multiply by 100, it will convert it to a percent. So let's go ahead and do that for our first one. We have the player scored 32 of the team's 110, and then in the end, we're going to multiply that by 100. When I go ahead and do 32 divided by 110, that gives us 0.29 when I round, 0.29, times 100. When I multiply by 100, in order to go from a decimal to a percent, I'm going to the right. I always tell students to just think of the alphabet. D comes before P. So in order in the alphabet to go from D to P, we have to go to the right. So we got to go right 2 spots. There's always 2 spots because I'm multiplying or dividing by 100. 1, 2. This is 29% for player A. So player A scored 29% of his team's points, which is outstanding. Player B, we're going to do part divided by whole times 100 again. This time the part is 25, the whole is 81 times 100. This time when we do 25 divided by 81, we get 0.31 when we round, 0.3086. And turning that to a percent, I'm going to multiply by 100. Again, D to P says shift to the right. Shift to the right 2. Player B actually scored 31% of his team's points. So what this means is even though player A scored more points with 32, player B scored a higher percent, scoring 31% compared to 29%. So player A did score more points. In terms of statistics, he scored more. But in terms of a percent, and we see percent a lot of times in like a circle graph, if you were to compare his portion of the circle graph, it would look a little more like this. This would be player A. It wouldn't be a huge difference, and this would be rest of team. But if you had player B, player B's would be a slightly larger portion of the pie. These are super inexact, I know, but I'm just trying to get the point across that player B scored a larger portion of his team's points, a bigger percentage. So that's how we'll use percentages to make comparisons and to measure growth. Sometimes it is better to use the actual statistic, the actual data point, like 32 compared to 25. Sometimes it's better to use percentages, and we'll get into when raw data is better than a percent and when a percent is better than raw data. Thanks so much for watching. Hopefully this helps you understand how to use percentages to make comparisons.